You reach for that 3/4 inch socket wrench you paid good money for, the one that has lived on your pegboard for 2 years like a trophy, and the second your fingers close around it, you feel it, that rough, gritty, crusty texture that sends a cold wave of dread straight through your chest. You pull it into the light, and there it is. A thick, cancerous layer of reddish brown rot, eating its way across the chrome like the metal itself is bleeding. You set it down and walk over to your project car, the one you have poured weekends and real money into, and you crouch down to get eyes on that critical suspension bolt you need to break free today. It is completely seized, not just surface dirty, seized, fused to the surrounding metal by a dense, porous crust of iron oxide that has been quietly growing for months while you were not looking. You grab the wrench, throw everything you have at it, and the bolt does not move a single degree. That is not frustration. That is a full-body, jaw-clenching, table-flipping rage that every person who has ever worked on a car or touched a real tool in their lifetime knows deep in their bones. So you do what the industry trained you to do. You drive to the nearest big box store, you walk down that chemical aisle, and you grab a can of whatever spray has the most aggressive-looking label. Industrial Rust Dissolver, Professional Formula, Maximum Strength. The can costs $12, sometimes closer to $20, and the second you crack the nozzle, the smell alone is enough to strip the paint off the inside of your nose. You soak the bolt, you soak the tool, you let it sit. The rust looks slightly better for about 4 days, maybe 5 if you are lucky, and then it comes back. Not the same rust, worse rust. Darker, deeper, more aggressive, spreading now into territory it had never touched before. You just paid real money to accelerate the destruction of your own parts, and nobody warned you that was going to happen. That is not an accident. That is the entire business model. Right now, sitting in your kitchen is a $1 combination that does something those $12 industrial sprays were specifically engineered never to do. It actually removes rust at a molecular level without harming the healthy metal underneath. The secret is a box of potato starch and a bottle of basic white distilled vinegar. When you combine those two things in the right way, you do not get a cleaning solution. You get what materials scientists call a chelation extraction gel, a thick, polymer-based paste that physically binds to iron oxide molecules and pulls them away from the metal surface, the same way a magnet pulls iron filings off a table. No toxic fumes, no aggressive etching, no damage to the underlying steel, just clean, original factory metal left behind after 10 minutes of contact. Before we go further, understand what is actually happening in that big box chemical aisle and why the brands lining those shelves have every incentive in the world to make sure you never discover what I am about to tell you. The rust repair industry is not in the business of saving your parts. They are in the business of creating a cycle of dependency where every time rust touches something you own, your only option is to come back and buy another can, another spray, another bottle, another tube, because the last one did not fully work and now the problem is spreading. They have spent decades building a marketing architecture entirely around one core lie. The lie is this: once rust starts, the metal is dying, and nothing short of a professional-grade chemical intervention can slow that process down. They need you to believe that rust is a terminal diagnosis for metal. They need you to believe that your rusty tools belong in the trash and your rusty bolts belong at the dealer, where they will cheerfully sell you a brand new part at a 300% markup. The moment you realize that a $1 paste made in your kitchen outperforms everything on that shelf, their entire business model starts to crack. Hit subscribe right now and join the Restoration Rebellion, because this channel exists for one reason only: to make sure the information that automotive chemical companies spend millions of dollars burying stays free and accessible to every single person who wrenches on cars, restores tools, or refuses to throw away something that can be saved. We are building a community of people who know the science, know the chemistry, and never again hand their money over to a corporation whose product is designed to fail. Now, let us talk about what is actually happening at a molecular level when rust forms on metal, because once you understand the chemistry, you will never look at a rust converter spray the same way again. Iron, the base material in your tools and your car's fasteners and every structural component under that chassis, is an extraordinarily reactive metal. In the presence of oxygen and water, Iron atoms shed electrons in a process called oxidation and bond with oxygen molecules to form iron oxide, which is the compound we know as rust. The critical thing to understand about rust, the thing the industry does not want on the label of their $30 bottles, is that rust is porous. It is not a sealed coating. It is a loose, crumbly, crystalline lattice of iron oxide molecules full of microscopic channels and voids that allow moisture and oxygen to keep penetrating deeper into the healthy metal below. Every day that rust sits on the surface, it is tunneling. It is creating new pathways for corrosion to reach untouched metal. So the question was never just, how do we clean the surface? The question is, how do we get into those pores, dissolve what is inside them, and extract the dissolved material out of the metal entirely so it cannot resettle? That is exactly what the potato starch and vinegar combination accomplishes, and here is the chemistry that explains why. White distilled vinegar contains acetic acid, a mild but highly effective organic acid that reacts with iron oxide and converts it into iron acetate, a water-soluble salt that can be rinsed away. Acetic acid absolutely attacks rust. The problem has always been delivery. Vinegar in its liquid form is too thin, too mobile, and too volatile. On a vertical surface, it runs off immediately. On a horizontal surface, it evaporates within minutes before it can penetrate deep enough into those rust pores to do meaningful work. And on a porous rust layer, the acid reaches the top layer, dissolves it, and then the solution becomes diluted and less effective before it ever reaches the iron oxide sitting deeper in the structure. The industry knew this, which is why they pivoted to phosphoric acid and other more aggressive chemical formulas. But more aggressive does not mean more precise. Now here is where the potato starch transforms the entire mechanism. Potato starch is a high molecular weight polysaccharide, a long-chain polymer made of repeating glucose units. When you mix potato starch into vinegar and work it into a paste, you are doing two things simultaneously. First, you are dramatically increasing the viscosity of the acidic solution, turning a thin, mobile liquid into a dense, slow-moving gel that stays in contact with the rust surface for the entire duration of the treatment. It does not run. It does not evaporate quickly. It sits there, pressing the acetic acid directly against the iron oxide with sustained, even contact. Second, and this is the part that makes this paste genuinely extraordinary compared to a simple acid soak, polysaccharide chains have a natural chemical affinity for metal ions. As the acetic acid dissolves the iron oxide and releases iron ions into the solution, the starch polymer chains wrap around those iron ions in a process called chelation. The word chelation comes from the Greek word for claw, and that is precisely what it looks like at a molecular level. The polymer wraps around the dissolved iron ion, locks onto it, and prevents it from reprecipitating back onto the metal surface. As the gel sits on the rust, it is simultaneously dissolving iron oxide with acid and kidnapping the dissolved iron with starch polymers, pulling the contamination away from the metal and trapping it inside the gel matrix where it cannot resettle. When you wipe the gel off, you are physically removing the iron that used to be rust from the surface of the part entirely. What is left behind is the original, healthy, unoxidized metal. That is chelation extraction, and it is the mechanism that makes this $1 kitchen paste outperform products that cost 30 times as much. Now, let me tell you exactly what is inside those $30 professional rust dissolvers on the shelf, because the ingredient list reveals the fundamental dishonesty of the product category. The most common active ingredient in premium rust converter and rust dissolver products is phosphoric acid. Phosphoric acid is a strong inorganic acid, and it is extremely effective at dissolving iron oxide. Nobody is disputing that. The problem is selectivity. Phosphoric acid does not selectively attack rust and leave healthy metal alone. It attacks iron, period. When you apply a phosphoric acid-based product to a rusted bolt, it hits the rust first because the rust is porous and exposed, and it starts dissolving it rapidly. But the acid does not stop at the rust-to-metal boundary. It keeps working. It etches into the healthy steel underneath, creating microscopic surface pits and craters across the entire treated area, including the sections that never had any rust in the first place. The manufacturers know this. The material science literature is unambiguous. Phosphoric acid etches steel surfaces when applied in concentrations strong enough to dissolve iron oxide at a practical speed. What those surface craters mean for you in practical terms is this. Every microscopic pit left behind by the phosphoric acid etch is a nucleation site. It is a tiny, rough-edged depression that provides the ideal surface geometry for new rust to begin forming. You have removed the visible rust, but you have replaced the smooth factory surface with a topography that is actively more hospitable to reoxidation than the original metal was. You are paying $30 for a product that removes rust today by creating the biological preconditions for more rust tomorrow. The improved formula versions with tannic acid additives are marginally less aggressive but still carry the same fundamental problem. They are designed for speed and visible surface results, not for the long-term health and integrity of the metal you are trying to preserve. They are selling you a short-term visual result while silently setting you up for the next purchase. Here is the exact protocol for using the potato starch and vinegar extraction paste, and you need to follow each step precisely because there is one critical warning at the end of this sequence that, if you miss it, will undo every second of work you have done and leave you worse off than when you started. Start with your ratio. You want approximately 2 parts potato starch to 1 part white distilled vinegar by volume. For a medium-sized rusted area, 2 tablespoons of starch to 1 tablespoon of vinegar is a practical starting point. Add the vinegar to the starch slowly and work it together until you have a thick, gooey, opaque paste. It should hold its shape when you scoop it, but still spread easily under a tool or your gloved finger. If it is too dry and crumbly, add a few drops more vinegar. If it is too liquid, add more starch. You are looking for the consistency of thick toothpaste or cold honey. Before you apply the paste, remove any loose, flaky rust mechanically. You do not need power tools for this. A stiff wire brush or even a wooden skewer to knock off the large, completely detached flakes is sufficient. You are not trying to grind down to bare metal. You are just removing the material that is already barely attached, so the paste has direct contact with the bound rust beneath. Apply the paste generously over the entire rusted surface. Do not be conservative. You want a thick, even layer covering every rusty area and extending slightly onto the surrounding clean metal at the edges. Press the paste into any crevices, threads on a bolt, or textured areas. The gel needs sustained contact with the rust to do its work. Now you wait exactly 10 minutes. Not 5, not 20. 10 minutes is the sweet spot for this chemistry. Under 10 minutes and the chelation process has not had adequate time to fully penetrate the rust pores and extract the deeper iron oxide. Over 10 minutes and you begin to risk leaving active acid on the surface long enough to start the initial stages of etching into the healthy metal, which is exactly what you are trying to avoid. Set a timer. At the 10-minute mark, use a clean cloth or stiff brush to wipe and scrub the paste off the surface. You will see the paste has changed color, pulling from a white or off-white starting color toward a brownish-orange tint as it absorbs the extracted iron compounds. That color change is your confirmation that the chelation mechanism worked. Wipe the surface clean and then look at what is underneath. Now here is the critical warning, and this is not an exaggeration. What comes next is not optional. It is not a recommendation. If you skip this step, you will ruin the part. After removing the paste, your metal surface is clean, slightly damp, and exposed. Even after the wiping step, microscopic traces of acetic acid remain on the metal surface at a concentration that is invisible to the eye, but absolutely active in chemical terms. If you leave those acid traces on bare, clean metal and expose them to air, you will trigger what metallurgists call flash rust. Flash rust is not the slow, gradual rust you are used to seeing develop over weeks or months. It is an extremely rapid oxidation reaction that can coat an entire clean metal surface in a uniform layer of bright orange iron oxide in under 20 minutes at room temperature. You will go from clean, shiny metal to fully orange metal faster than it takes to find your next tool. You must immediately neutralize the surface with a baking soda and water rinse. Mix 1 teaspoon of baking soda into a cup of water until dissolved. This is a mild alkaline solution, and when it contacts the trace acetic acid remaining on the metal surface, it triggers a neutralization reaction that converts the acid into sodium acetate and water. both of which are completely harmless and do not promote oxidation. Apply the baking soda, rinse liberally to the entire treated area. Scrub it lightly and rinse with clean water. Then dry the surface immediately and completely with a clean cloth or a shot of compressed air. The moment the surface is dry and neutralized, the flash rust threat is eliminated. If you are not planning to coat, prime, or reassemble the part immediately after this process, apply a thin layer of a clean machine oil or even basic WD-40 to create a temporary oxidation barrier until you are ready for the next step in your restoration. Now compare what you just accomplished against what the $30 bottle offers. You paid $1 for materials that are already in your kitchen. You used a chemistry that selectively targets iron oxide and extracts it from the metal without touching the healthy substrate underneath. Your treated metal surface is smoother, stronger, and less prone to re-rusting than it was before the corrosion started because the chelation process extracts iron ions that were already beginning the oxidation process in the subsurface layer, clearing the way for clean metal. The $30 phosphoric acid product gave you a fast visual result while microscopically damaging the surface, setting the stage for accelerated re-rusting, and cost you 30 times more for the privilege. The junk pile of rusty wrenches, sockets, and seized bolts sitting in your garage right now is not trash. It is a restoration project waiting for 10 minutes and $1 worth of kitchen ingredients. Share this video right now with someone you know who has written off a pile of rusty tools or a car full of corroded fasteners as a loss. Because the only reason those parts are sitting in the scrap pile is that nobody told them the industry was lying about what rust actually is and what it actually takes to fix it. The information exists, the chemistry works, and the $1 is already sitting in your pantry.